I repaired this PCB for the first time, but the unit is still having problems. This is the indoor unit, and this is its outdoor unit. When I'm giving it electricity, as soon as I turned the electricity on, the indoor unit started running, and the outdoor unit also started running, and the LED of its outdoor unit also turned on. And here at this time, the indoor unit is working at 16-degree temperature. We will wait. The indoor fan motor is working properly. Now look here, the F6 error is appearing on the display. This PCB came to me for repair because this outdoor unit was not turning on, so I repaired it and gave it back to the customer. But despite this, the F6 error is still appearing on the display. Now the F6 error is a communication error, which means the indoor unit and the outdoor unit are not able to communicate with each other. They are not able to talk to each other, because of which this issue is happening. Now we will turn it off. I am removing the switch. Now, here we have the PCB of this magnet, so it feels to me that this PCB has a fault, because I checked the outdoor unit and it seemed completely fine to me. Now here, these two optocouplers installed here, and all the diodes connected with them, complete the communication procedure for the indoor unit. And in this, the one on the right side takes the data outside for the outdoor unit, and this second one brings the data inside the PCB for the indoor unit. So first of all, I will check whether the indoor unit is giving a signal to the outdoor unit or not, because this PCB is its startup PCB, meaning it has to send the hello signal to the outdoor unit first. Then the outdoor unit will respond. So when this signal goes, the whole procedure will complete. Now here, look, I have soldered 2 pins. The purpose of soldering them is so that we can properly see the signal, because as soon as this board turns on, it sends out its signals. So what happens because of this is that if we get late, then we are not able to see those signals, because of which the issue happens. Because I am remembering something, that I had worked on this board before, so its indoor unit sends the signals first towards the outdoor unit. Now let's check whether actually the indoor unit sends the first signal or hello signal to the outdoor unit or not. Now here, look, I am directly connecting the oscilloscope probes. Now my hands are completely free. So as soon as the signal comes, we will easily be able to see it on the oscilloscope. Now I have turned on the PCB. The PCB turned on, we will wait. From here, there is no kind of signal, so the indoor unit did not generate any kind of hello signal. Look, right now we should not have 50 volts here. Let me reduce it to 5 volts and check again. Look, it automatically goes to 50 volts. Now in the same way, let me also check the outdoor unit, whether it outputs a signal or not. So I am connecting the signal to the outdoor unit, applied the electricity, so the signal is coming from here. Look, the outdoor unit is sending the first hello signal. Look, packets are coming here. This means that its outdoor unit sends the hello signal first, then the indoor unit does its work. So this signal is currently going out from here, meaning that the outdoor unit is doing its job. Look, 694 hertz are coming, different hertz, and different packets are coming, which are going towards the indoor unit in different forms. Now I have properly connected the connections of both of these. Right now I have not given electricity yet. But look, some lines are appearing here. The electricity is not on yet. So let me give it proper electricity. So I gave it electricity. It turned on, and let me reset it again. Now let's see whether the signals are reaching here or not. I have set this on the receiving point for the indoor unit, meaning the anode and cathode that receive the signals for the indoor unit. But the signal is not reaching here. Look, there is absolutely no signal. Look, completely zero. Nothing at all. So this means that the signals are not even coming here. Look here, the F0 error has appeared on the display. So F0 is a fan motor issue. So let me connect the motor here. Now, what I have done here is, I disconnected this signal wire from here. After that, we will check only the outdoor PCB signal here. I have supplied power to it, and now we are going to see whether the signal is transferring properly or not. As you can see here, the voltage reading is around minus 1.3 volts. and after some time it should increase further. If it fluctuates even once, then it will confirm for us that the voltage here is working properly. As you can see here, the packets are coming, but the voltage is staying around 1 volt, about 1.29 volts. It should fluctuate a little more up and down, but this confirms that the signal is present. Look, now it has changed. The packet has changed. It went from 0.9 volts to around 1 volt, because this packet changes after some time. And see, the packet changed again, and then changed once more. So in this way, it is fluctuating. This means the outdoor signal is reaching this wire, but through this signal wire, it is not reaching the indoor unit properly. Right now, the outdoor signal is reaching this point of the indoor PCB, which means the issue is somewhere in this circuit section here. As you can see, there are some diodes here, along with a few resistors installed in this section. So this part is not working properly, because of which the signal is not passing toward the indoor side. Now we will check all of these diodes one by one. If we look at it right now, it appears to be completely okay. Now what we will do is switch our probes. When we test it in reverse bias, it is showing okay. Then when we connect it again, it still appears perfectly fine. So we have to check both the forward bias and reverse bias conditions to get a proper idea. Yes, this one is also fine. Let's check this one as well. Now you can see, we have already checked it in reverse bias, and now we are testing it in forward bias. This one is also okay. So all the diodes installed here seem to be perfectly fine. I cannot see any issue in them. Now let's check it in resistance mode as well. So this one is showing around 130. But here you can see that the 100K resistor is showing in mega ohms because there are many diodes connected around it. That's why we will remove it and check it separately. Otherwise it will not display its correct value. In the same way, there is another resistor connected near the optocoupler. Let's check this one as well. It also appears to be a 100K resistor. And as you can see, it is properly showing 100K resistance. So this one is fine. Now this one here is a 2K resistor. Let's check it too. It is also showing 2K correctly. So this means there could be a fault in the R20 resistor installed here. Or there may be a fault in one of the diodes connected in this section. Since all of these components are showing their values correctly, it is not possible for us to identify exactly which component should be replaced. So, this D8 is a normal diode, while ZD4 is a 24-volt Zener diode. In the same way, ZD1 is also a Zener diode, and ZD2 is another Zener diode, whereas D6 is a normal diode. So now in the first phase, what we will do is replace the Zener diodes first. Now specifically, we will remove this resistor and check it separately. Let me test this resistor now. And see what it shows. As you can see, it is showing exactly 100K resistance. Now, we will simply use the multimeter in DC voltage mode to check whether the voltage here is fluctuating up and down properly or not. So, let me turn the power on. I switched on the electricity and the PCB is now running. Let's check it. And as you can see, proper voltage is now coming here. This means that the communication between the indoor and outdoor units has started successfully. Now we cannot confirm exactly which component was faulty, whether it was one of the diodes or the resistor, but I replaced all 3 diodes along with the resistor. The benefit of doing this is that it saved a lot of time. If I had checked each component one by one in detail, it would have taken much longer. Let's do the final testing. I turned the PCB on, and now the fan motor has started. We will wait a little, and as you can see, the compressor has also started. So now, the F6 error has been completely removed, and the compressor is running properly. Everything is now working correctly. Now let's turn the system off with the remote. As you can see, the compressor has started slowing down, and now it has turned off completely.
Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.